Hey guys, and how you going for one last time? And today I just want to be talking about what type of platforms do we need to use to get our images from. So maybe you've chosen like Nearmap or something else, some sort of a client or a supplier of images for your client, right? So there are a few different options that you can choose from. And if you go to satimagingcorp.com, you can scroll through a few different versions of satellites. You can't do a bunch at a time, just so you know. Just do one at a time. And you can see their different resolutions and their different specs. So whenever a client comes to you and they say, I want to look at, say, maybe like vegetation or say like buildings in rural areas, let's just say. So you have to consider three things when you're looking at your feature. So the first are the spatial dimensions, the spectral dimensions, and the temporal dimensions. So in selecting a satellite, buildings spatially, you need to consider two things spatially. You need to consider the size of the feature. And when you're considering the size of the feature, make sure that your pixel size will have to be 1/4 the size of the feature. So let's say a building is, 20 square meters. That means that I would need a pixel size of, say, 5 square meters. And the entire spatial area that I'll be looking at, the rural areas, let's say I'm looking at just one rural area, that might be an entire area of, say, 10 square kilometers, right? So I need either a plane or a satellite. And in choosing a plane or a satellite, it really depends on if you're considering active or passive sensors. So active sensors, they can be satellites, but they're usually planes shooting down a beam and receiving it back up. And passive sensors are usually your satellites, which receive light that's rebounded from the Earth, originally from the sun, being projected from the sun. So, as an example, there are a bunch of different satellites here. Let's just choose one random one. We'll say, Rapid Eye. That'll be good. Choose Rapid Eye. So Rapid Eye has a dimension of 5 meters per pixel, right? And we can see their dimensions. Here are some sample images of their quality that they can be used for. So what we need is buildings, right? Spatially, 5 meters is good. And then we need to consider how much area it's good for. The Rapid Eye system collects an unprecedented 4 million square kilometers of data per day. Usually somewhere in the description it says something about the type of areas they're used for. Somewhere here. Swath width, 77 kilometers. Yeah, I suppose that should be about it. Usually somewhere in the description it will say like 60 by 60 square kilometers, or 60 by 60 kilometers, which will be 60 square kilometers or something like that. But anyway, assuming that the spatial dimensions are correct for this, we can then consider this is a ground sampling distance of 6.5 meters. So that's like it's kind of like the pixel size almost. We can then consider the spectral dimensions. So your spectral dimensions are your wavelengths. So we need to consider what lights do buildings reflect or not reflect. So let's just assume for a second that all the building tops were red or something. So, or maybe not red, maybe green. So green it reflects green light, and let's say it reflects near-infrared light as well. So assuming that our building tops were all green, right, we would need, you pretty much always need visible wavelengths, so you need blue, green, red, and then it's always good to have near infrared as well, especially for like vegetation as well. And you might also want a satellite which uses shortwave infrared, which is SWIR. That's good for seeing through smoke in case there's a fire, and it's also good for seeing through thick clouds and stuff like that. So, assuming that this satellite was good spatially, which it is with 5 meters, and spectrally, assuming it's also good again, we can then also look at its temporal dimensions, and this will usually come at a revisit time. It's highlighting everything. revisit time. So this is how frequently the satellite, in this case, goes back over the site, or goes back over the area that it looks at. So this goes over the same point, the same area every 5.5 days. That means every 5.5 days you can get a updated picture. Now you just have to consider temporally, does my feature change? Well, my feature may not change at all between years because it's a building. Unless a building is going to be demolished, it's pretty much never going to change, right? So we can assume that even though it goes over 5.5 days, we won't be needing images that frequently. Oh, and here's the image capture capacity, 4 million square kilometers per day, in case you wanted to know that as well. And the pixel size is here, that's where it was, that's what I was looking for, 5 meters. But yeah, so temporally, images are collected very frequently. We don't need that. We may only want to collect images, say yearly, or maybe every second year or every third year or something. It depends on the feature that you're looking at. So after you've selected what platform you need, so if it is an area that a satellite does not capture or does not capture in enough detail, chances are you'll need a plane to do active sensing, or you may also have a plane which uses passive sensing, which is entirely possible. So you can either choose a plane or a satellite or a hot air balloon or something. Assuming you're choosing a satellite, you can come to this website and choose a satellite type depending on the pixel size you need. And so when you're looking at a feature, consider the spatial dimensions, which is the size of the area and the pixel size. The spectral dimensions, which are what does my feature reflect, what does it absorb, and what does it transmit through. So there's absorption, reflection, transmittance. And then there's also temporal dimensions of my feature. How frequently does my feature change? So those are the three major things you have to consider when you're answering a question, or when you're intending to do some sort of classification or to look at near-infrared light that's being reflected back or something. So here you're looking at crops. Crops change weekly. So, or it might be like every 3 days might be a pretty good picture. So that might be the type of stuff that you're doing. So here is where you would see what satellite I need to get data from a source, and then do some analysis and then send it on to a client for them to look at your analysis and make a deduction about what's happening. So they might choose I don't want to grow crops here because I can look at the SWIR, which is the shortwave infrared. I can tell that the soil doesn't have any moisture content, because shortwave infrared is also good for moisture content, as well as looking through cloud cover. And he might decide, or she might decide, that the soil has no moisture in it, therefore I don't want to set up a farm there or something. Yeah, but that's about it. I hope you guys have learned something and have a great time. And that will be the end of this series. In my next series, I'll be doing Spectral Python, which is essentially a Python package which has a number of modules within it. These modules you can think of as like NV toolbox tools, and the Spectral Python is a package which is kind of like the NV program in its completeness. So that's what I'll be doing. You can think of it as a way to automate the process of using NV, or it might just be an easier process, even if you don't want to use machine learning to automate it. But anyway, I hope you guys have learned something. So have a great time and see ya.